It's a deep cone. It actually has 63.5-degree sides. It's about a meter deep with a little dome on the bottom, and it has a drain in the bottom. And the drain allows us to drain the quench water out, which is smoke water. There's a little grate in the bottom to stop the char falling into the drain pipe, 70mm diameter. And then the other grate above that with large 150mm square grid. We'll be putting long sticks in there, layering it, and the char will break up and fall through.
So we built now the first layer on the grid to avoid that smaller pieces fall down uncharred. And on top of this first layer, we're going to build now the pyramid that we will top it to create the heat to start the charring process.
Okay. And then once we get it going, we can scatter it out.
One match, 500 kilograms of biochar.
Yes.
2 matches.
Maybe 2 matches.
Just to build the stress with the pyramid.
Now we're going to continue to have some smoke until we can spread the fire across the whole kiln and begin to create that draft effect that moves all the smoke into the fire.
We just spread it like 2 minutes ago, and now we have no smoke anymore. We already get the small loops. We have the fire in the middle. It's difficult to see. If you have no smoke, what are the dynamics? When you see these white ashes starting to appear on the surface of the wood, it's time to put the next layer.
Yeah, and of course this layer is a bit haphazard because we just knocked the pyramid down.
Yeah. You see some white on the surface layer. Some ashes shows that oxidation gets into the process. So to put the next layer to deliver more wood gas to fire above the wood and get back the heat by reflection and pyrolysis.
I'd like to explain what we learned about how the draft does work on this kiln. What's going to, when the kiln is hot and there's an updraft in the center, it's pulling air up around the edge of the cone, and that air rising, even preheating a little bit, coming up around the edge of the cone, updrafting here, pulls air from the inside of the cone. Okay, so that it trains the air like this, and then that pulls air over from the center of the cone, which then pulls air down in the interior of the cone, and then pulls air across from the outside. So you end up with a loop in here like this. So this updraft creates a loop, a toroidal vortex all the way around the cone, which feeds oxygen in and down into the material in the cone. But the vortex may vary in size, but it's something like about this size. So it penetrates about so far down into the kiln, 50, 60 centimeters down into the kiln, and the material at that level can in fact the char can begin to oxidize and turn to ash. So as that happens, we layer another layer of wood on, and the flames and the updraft from that layer of wood then that keeps the oxygen away from the layer below, and it just keeps all settling down into the base of the kiln, the biochar that's created. Coming back up to our kontiki, you can see we've got a layer of ash on there now, so on the top, so we'll put another layer of wood over the top of that. we threw some manure on there, so that's drying out and smoking a little bit. But what the smoke helps you see is the convection, and so over there you can see this, there's a vortex, a horizontal vortex being created as the air is updrafted past the edge of the kiln on the outside, and it drags the air up on the inside, so it pulls air across horizontally and smoke across horizontally in the kiln from the center towards the outside, and from on the top it drags it back towards the center and creates a vortex out there. And you can see the shimmer there. There's no smoke. And we're adding another layer now, which of course will disturb the fire a little bit, and you'll see a little smoke, but it's going to get caught in the flames. Very, very clear how that smoke is coming out and going sideways. Except when it's disturbed by the wind, it basically is going horizontally, radially outwards.
But what's really interesting and fascinating that cutting a trunk like this somewhere, the energy you need to cut it here is the same energy that you gain when you break up the molecules that are inside by the heat. So recovering the chemical bonding energy is very important, and the less we have to cut it, the more energy we get out of it and recover. So this is the day after. In the morning we quenched it yesterday night, and as you can see, the water on top of the kiln is crystal clear water. Char is without odor. You can see Paul's hand like in a crystal clear river. Interestingly, the water is a little bit soapy on the feeling, or we'll measure the pH and look where that might come from. It seems that all of the pieces we can see here on the top layer are finely calcinated. There's no non-calcinated parts that we discovered. It breaks very nicely and you have beautiful biochar structure. So this water is still clean, after 100 liters, the whole water that we get out of the kiln is like filtered water, which is really a very satisfying sign for this technology.